Last time we talked about analysis of variance, and in particular a form of analysis of variance or ANOVA called completely randomized analysis of variance, in which persons are assigned randomly to one and only one of the groups or conditions in the study. That is, they're assigned to one and only one level of the independent variable. We had worked our way partway through a problem or an example dealing with the effects of watching various amounts of violent television content on children's subsequent aggressive behavior. And we had assumed that aggression was it was measured. Calling Sigmund Freud, we had assumed that aggression was measured by the frequency with which each child struck a Bobo doll subsequent to viewing the television content. And we had discovered, as I recall, that we had sufficient evidence to reject the null hypothesis. And the null hypothesis was that x bar 1 equals x bar 2 equals x bar 3 equals x bar 4. That is, that all four of the group means would be equivalent. And we had rejected that null hypothesis, concluding that the amount of violent content watched by children significantly influenced the amount of aggression they subsequently enact, the amount of aggressive behavior they subsequently enact. Yes? Are there any questions about ANOVA to that point? Then let's go on. What we had not determined was precisely why we had rejected the null hypothesis. That is, we did not know which group or groups differed from which other group or groups in their level of aggressiveness. In order to make that determination, you need to employ a test of difference. A test of difference. And there are any number of these tests. And you don't need to recall these, you don't need to take note of them, but Tukey's least significant difference test, Dunet's test, Chaffee's S test, are examples of this sort of test for differences between means. We're going to use one, and again, it doesn't really matter because you won't be required on the exam to distinguish between these or to select one or to indicate why one may be preferred over the other. But we will use one that is called Tukey's honestly significant difference test. Each of these tests generates a value, a single value. And if we were to apply Tukey's honestly significant difference test to these data, we would discover that the value of that statistic was 1.75. I have identified here x bar 1, x bar 2, x bar 3, and x bar 4. And the means, that is, the means of each of the four groups. And I've further operationalized what these groups watched in a sense. One group, group 1, watched some amount of content in which, let's say 15 minutes of content in which there was no violence. A second group watched 15 minutes of content that included low levels of violence. A third watched 15 minutes of content in which there were moderate levels of violence. And the fourth group watched 15 minutes of content in which there was a high level of violence. This is a standard research strategy. And you obviously have to, the researcher has to operationalize each of these levels. Operationalizing none may be relatively straightforward, but then distinguishing between a low level and a moderate level and a moderate level and a high level of violence typically requires some external judgment by a group of prior observers. Nonetheless, that's the sort of research context. Are there any questions that deal with this part of the context? Then the issue is, how do you go about applying Tukey's test? What you do is you compare it to, you use it to make the comparison between each mean and each other mean. That is, you have to compare x bar 1 to x bar 2, x bar 3, and x bar 4. You have to compare x bar 2 with x bar 3 and x bar 4, and x bar 3 with x bar 4. Those are all the pairs, would you agree, available using these four groups. Where the observed difference between the two groups exceeds this critical value of Tukey's test, you would conclude that those two groups differ significantly. Where the observed difference between the two groups is less than this critical value of Tukey's test, or whatever test you're using, you would conclude that the two groups do not differ significantly. Let me point out two things here. As I indicated at the beginning of this discussion, no matter where you start from, no matter how complex the research design, ultimately you get into the business of comparing one group with one other group. Second, while this is Tukey's test, we're going through the same process as we did with t-test, when we conducted a t-test and a z-test. That is, we're comparing a critical value with an observed value. And where the observed value exceeds the critical value, we will conclude significant difference. Where the observed value is less than the critical value, we will conclude no significant difference. Are there any questions about this, the process of using Tukey's test to test for between group differences? If not, let me ask you, is the difference between group 1 and group 2 significant or non-significant? You would argue that it is not significant. 3.5 minus 2.5 is 1.0, which is less than the critical value. That is, the observed difference is less than a difference that will occur by chance if chance is defined as the level of alpha that we use, 0.05. What about the difference between group 1 and group 3? You would conclude that those two groups differ significantly. 6.25 minus 2.5 is 3.75, which exceeds the Tukey's value, the critical value. That is, the observed difference exceeds a difference that will occur by chance. How about the comparison of group 1 and group 4? You would conclude that those two groups differ significantly as well. What about the comparison between group 2 and group 3? That too you would conclude is significant. How about between group 2 and group 4? Significant. And between group 3 and group 4? You would conclude that that is significant too. The only non-significant difference is the difference between X bar 1 and X bar 2. Yes, that is between the levels of aggression exhibited by children who watched television content that included no violence and television content that involved low levels of violence. Would anybody care to put, well, first of all, before I ask that, are there any questions about this process of determining significance or non-significance between the group means?
I have a question about Tukey's value. Would we be given that? Or?
We're asking exam questions again, aren't we? Will you be given Tukey's value? Yes. Yes. Are there any other questions about the process of comparing the group means? Would anybody care then to try to summarize the findings of this study? I'm sorry, I'm falling asleep. Yes.
That the greater amount of violence shown to a child significantly goes up with aggression, with the more violence?
Close. Close. To say that as the amount of violent content increases, so too does the amount of aggression displayed subsequently by the child, is true except for children who watch content that includes no violence and content that includes low levels of violence. That increase did not produce a significant difference in subsequent aggressive behavior. So you're close. You're close.
I have a question. What if you have 3 no significance and 3 significance? Would you have to fail to reject the claim then?
No, these are independent judgments. The overall test is the overall analysis of variance. We know we've rejected the null hypothesis. We're now in a secondary phase where we're really testing, in this case, 6 null hypotheses. But we know already from the overall ANOVA that we've rejected the primary null hypothesis. The null hypothesis here, of course, is that X bar 1 equals X bar 2, X bar 1 equals X bar 3, and so on and so on. You can summarize this in any number of ways. You could add to the statement that was made, except, and then indicate, that moving from no to low levels of violence does not produce a significant difference. one could also say that viewing moderate or high levels of violence in TV content produces significantly higher levels of subsequent aggression than watching no or low levels of violent content. And watching content that is high in violence produces a significantly increased exhibition or display of aggressive behavior than watching similar content that includes only moderate levels of violence. However you do, whatever words you use to summarize this effect, you understand that the significant differences are between X bar 3, X bar 4, and X bar 1 and 2, and then between X bar 3 and X bar 4. There is no significant difference between X bar 1 and X bar 2. So that this relationship is not linear. That is, the relationship between amount of violent content and subsequent aggressive behavior is not linear. It doesn't increase across each of these levels of the independent variable amount of violent content, because it does not increase significantly between no and low levels of violent content. Yes?
Are we supposed to judge the direction of the difference by whether or not the number's positive or negative, just like in the two-tailed test with t-testing?
I think I know what you mean.
You're like, in this test you're going to say they show significantly more violence than significantly less violence because the difference is positive.
That's right. That's right. Yeah, at this stage we're going beyond simply the levels of violence differed significantly, because it's apparent from the data that for all of the significant differences are upward differences. That is, there are differences associated with increased aggressive behavior. Is that answering the question? Okay. Are there any other questions? There are probably students sitting at home next semester going, "Ooh, ask this question. Somebody ask this question." Instead, I'll get an email. You know? We will go through additional examples of analysis of variance after the spring break. The other thing I want to do this morning is to look at interaction effects. So let me, before doing that, ask one more time, are there any questions dealing with what we've discussed about ANOVA so far? Going once, going twice, sold. We have looked at the moment at one example of ANOVA, and it's the simplest form of ANOVA. It's simply, would you agree, an extension on uncorrelated t-tests. That is, in an uncorrelated t-test, we had a single independent variable, A, that was hypothesized to affect a single outcome variable, B. And we have when we were talking about z-tests and t-tests, A had two levels. That is, there were two groups. all we've done thus far is extend beyond two groups. And when you extend beyond two groups, t-testing is no longer appropriate. That is, it is not appropriate to take the four sample means here, x bar 1, 2, 3, and 4, and compare each mean with every other mean by using a t-test. When you're dealing with more than two groups of an independent variable, more than two levels of an independent variable, you're into the world of ANOVA. But it's, as I've indicated, the simplest form of ANOVA because you still have just one independent variable and one outcome variable or dependent variable. I'll say a word about the dependent variables first because this is something we will not explore any further. But there, as I indicated, I believe, last time, there are clearly occasions when a researcher is interested in more than one outcome. If a researcher is interested, for example, in SAT performance of males and females, the researcher would have a single a single independent variable that would have two levels. One level would be males or maleness, and the other would be females or femaleness. But the researcher may have more than one dependent variable. The SAT, I believe, is comprised of, is it a verbal section and a quantitative section? So we could have two dependent variables. The verbal score and the quantitative score. Would you agree? Yes or no, or maybe, or you said we weren't going to talk any more about this, so I'm really not paying attention because it's just a transient issue. When you have more than one dependent variable, you are into something called multivariate analysis. And this would be multivariate analysis of variance. That is, multivariate ANOVA. When a researcher is dealing with more than one dependent variable, the appropriate form of analysis is multivariate analysis. That is, you can't, if we go back to the SAT example, you can't conduct one ANOVA in which you examine the effects of gender on verbal scores and a second independent ANOVA in which you examine the effects of gender on quantitative scores. Because the two scores are not independent of one another. The scores, the verbal scores and the quantitative scores, come from the same person. And although people have this, often invoke this notion that, oh, I'm a words person, not a numbers person. Verbal ability and quantitative ability tend to be positively correlated. That is, the higher your verbal ability, the higher your quantitative ability is likely to be, really. And it's obvious why. Because a lot of those quantitative questions include words. It's not just numbers set out before you in some particular order that you use to solve the problem. So verbal ability and quantitative ability tend to be positively correlated, Whether they're positively correlated or negatively correlated is, in a sense, irrelevant. The fundamental issue is they're correlated. So that you must examine them together and not independent of one another. So I come back to the original statement that I made. You have to use multivariate analysis of variance in this instance so that the scores, the verbal scores and the quantitative scores are taken as a unit, as a correlated unit. And multivariate analysis of variance is set up to do precisely that. I say this because you will, I'm sure, come across research in which the researchers are confronted with this situation and they do in fact conduct independent tests of the two sets of scores. And if you see that, you rip the article out of the journal, you go down into the main lobby of the library, you take out a lighter and you set fire to this study in public. That's what I would do. It's not worth looking at. Or you might decide just to not take the results seriously. We can add to this basic building block in another way. That is, we can argue that changes in A cause changes in B, but also that changes in C cause changes in B. We would have, at that point, not one, but two independent variables. Would you agree? We could, for example, in the study that we looked at, we had a single independent variable with 4 levels. We had amount of violence in the content. Yes? And we had 4 levels: no violence, low violence, moderate violence, and high violence. Yeah? I should write that here. So we had A1, A2, A3, and A4. Yes? Everybody willing to go along with me so far? I don't hear anybody saying no, so I'm going to go on. We could add a second independent variable here and argue that the reaction to the violence depended also upon gender. If we argued, for example, that males are generally more violent than females, we might argue that males would react more aggressively to the violent content than would female children. That is, we would have a second independent variable, gender, which would have 2 levels, males and females. I'm sorry, I've used the B as an outcome variable. What I need here is C. We would have C1 and C2. So we would have not 4 groups rather, we would have 8 groups. Are there any questions about this extension? Yes.
So just what does it say on top? Is it
amount of violence?
Yeah, I know that. A1, A2, A3.
You want me to write clearly on this thing, don't you? I think it's plain to all and sundry. I can't do that. We had A1, A2, A3, and A4. And those groups represented receipt of different levels of violent content. Yes? Are there any other questions about this extension to include a second independent variable? This is independent variable I, and this is independent variable C. If we were to conduct an analysis of variance in this case, we would be testing for the effects of I and the effects of C, would you agree? We would be testing for the effects of level of violence in the content, and we would be testing for the effects of gender. These are called main effects. Main effects. We would, however, also be testing for the interaction between A and C. And these are the interaction effects. The main effect should be straightforward to you. In order to test for the effects of A, levels of violence, we would ignore whether the child was male or female, and we would compare the mean of this pair with the mean of this pair, with the mean of this pair, with the mean of this pair. That is, we would compare A1 with A2 with A3 with A4, just as we did previously. In order to test for the effects of gender, we would ignore the levels of A. That is, we would average C1 scores across each level of A and C2 scores across each level of A, and compare what are called these two marginal means. Essentially a t-test in this case, because we just have two levels of gender. But this would be done through analysis of variance. The interaction effects are a comparison of each of these means, these cell means, with one another. It's a test of whether the effects of one independent variable vary across levels of the other independent variable. I don't know how many of you are going to go out and watch this tape, but if you're not, you might want to write that down. See? Well, can you now say it again? I'm sorry. I was taking a nap there. I was on a rest break. I was actually down on South Padre Island already. I was at the airport. I was wondering whether I should take one bag or two, or can I still do that? Can I still take water on there if I buy it in the airport? You know, I know what I'll do. I'll wear sandals, because I've got to take the sandals off, and I don't want to, you know. Can I say it again? Yeah. Oh, you mean now? The test of interaction effects in this case, a test of interaction effects, is a test of whether the effects of one independent variable vary across levels of the other independent variable. It's a test of whether the effects of one independent variable vary across levels of the other independent variable. Yeah, it's a test of whether the effects of one independent variable vary across levels of the other independent variable. Let me show you a case in which this is a case of an interaction effect. Let us presume that the mean of A1C1 is 3 and the mean of A1C2 is 6. And let's assume that all of these differences across gender are significant. Let's presume that the mean of A2C1 is 6. The mean score of A2C2 is 4. The mean of A3C1 is 8. The mean of A3C2 is 4. The mean of A4C1 is 12, and of A4C2 is 4. We can then compute these marginal means. 12, 20, 29 divided by 4 is 7.25. 6, 10, 18 divided by 4 is 4.5. 9 divided by 2 is 4.5. 5, 6, and 8. Would you agree? If we were to assume that each of these differences is significant, would you agree that we would conclude that as amount of violence increases, so too amount of violence in the content, so too does subsequent aggressive behavior?
Gender C1, right?
At the moment, we're not interested in the effects of C, gender. What we're interested in at the moment is the effects of levels of violence. That is, the difference between A1, the differences between A1, A2, A3, and A4, disregarding levels of gender. And since these scores increase across levels of gender, across levels of violence, and if all of those between group differences are statistically significant, would you agree that we would conclude that as amount of violence in content increases, subsequent levels of aggressive behavior increase? That's just looking at these four marginal means. Would you agree that if we look at these two marginal means, that is, if we look at the means associated with the gender effects, we would conclude that males are more violent than females? I'm glad we can have this unfilled silence between us, you know. It suggests that we share a relatively close relationship. You know, when you're so comfortable with one another, you don't have to talk. Unfortunately, because this is a classroom, one of us has to talk. It's more informative that way. Would you agree? I've said before that we won't talk about exam questions. This is going to be on the exam. You're going to have to do this. Would you agree that if we look at the marginal means associated with gender, we would conclude that males are more aggressive than females? Yes. So we would conclude, first of all, that as the amount of violent content increases, so too does subsequent aggressive behavior. And we would conclude, second, that males are more aggressive than females. When you look at the cell means, is that true? Are either of those statements true? No. No. The first statement we made was that as level of violent content increased, so too does subsequent aggressive behavior. That doesn't describe the pattern of score of female scores. It does describe the pattern of male scores, but not the pattern of female scores. So that statement is false. We concluded, second, that males are more aggressive than females. When you look at the cell means, is that always true? No, because when there was no violent content, actually females behaved more aggressively than males. I'm not saying a word, so I'm leaving that one way alone. So that statement isn't true either. That is, the effects of A, the main effects of A and C, are uninterpretable because the interaction between A and C is statistically significant. That is, the effects of one variable change across levels of the effects of one independent variable change across levels of the other independent variable. And in this case, what you would discover, and we're not going to go through the tests that you would have to perform to determine this, but you would conclude that when television content contain no violence, females behave more aggressively than males. However, when content includes violence, males behave more aggressively than females. Suggesting, and we could, clearly this is hypothetical, but we could explain this by arguing that watching violent content serves to activate aggression in males, whereas it acts to subvert aggression in females. The explanation for this is irrelevant because we're not dealing with an actual study here, and the focus is not on the why. The focus is on what sorts of conclusions do you draw from the data? And when the interaction between the factors is statistically significant, the main effects of each factor are uninterpretable because the effects of one independent variable change across levels of the other independent variable. Are there any questions? Is there anybody saying, I just don't get this? Yes?
Did you say we don't have to do much of the multivariate analysis? Like, we're not going to focus on the two or more dependent variables?
You should know, however, that when you have more than one dependent variable, the appropriate form of analysis is multivariate. Are there any other questions? Yes?
Can you say one more time why the main effects of the A and C are uninterpretable?
The main effects of A and C, that is, the main effects of the independent variables, are uninterpretable because the interaction between the variables is statistically significant. And what that means is that the effects of one independent variable change across levels of the other independent variable. That is, the effects of A change across levels of C, and or the effects of C change across levels of A. Yes?
So, if the main effects were interpretable, does that make the interaction effects uninterpretable?
No. No. These main effects become interpretable when the interaction effect is non-significant. So if you were to look at the interaction effects and the p-value was greater than alpha, you would conclude that the interaction between the factors was not statistically significant. That is, you would not focus on the cell means, and then you would look at the main effects, and if in both cases p was less than alpha, then you would explore both sets of marginal means. Because you have significant effects due to A, which is level of violence, and main effects due to C, which is gender. And that would be the case, for example, all we have to do here is change the scores at A1. And if this were the case at A1, then there would be no interaction effect. Are there any questions? Any additional questions? This is now the conspiracy of silence, right? This is every one of you reaching out telepathically to everybody else in the room, saying, don't ask a question. Don't ask a question, because then we can get out of here. If there are no more questions, you folks have a good spring break, and I will see you afterwards.